So now we're going to talk about the polar form of a complex number. And you might be saying, well, why would I want to do that? I was happy enough with the complex numbers, before. Well, there are certain things we can do when it's in polar form that are a lot easier to work with than having it in rectangular form. Okay, so draw some axes here, and we'll call this the real axis and this the imaginary. Okay, and then think about some point out here, right? Okay, we can draw a triangle. Now, when we were working with polar coordinates, so let's say this is on a circle. Let me draw it. Ooh. Some circle. Okay. We can think about this point right here as being x plus yi. We can think about this being x, this being y. So we've already done that. We can think about, now switch to polar here, we think about this as the radius, and we think about this angle here as theta. Okay? Now that has it all. It's got your complex number and it's got that superimposed circle so that you can have a theta of rotation and a radius for that circle. Okay. Then we can go back to some of the things we've done in the past, such as we said x is equal to r cosine theta, and we said y is equal to r sine theta. And we also said r is equal to the square root of x squared plus y squared. So all that came from when we were working with polar form in the past. Okay? The modulus is going to be the absolute value. I'll pretend like that says absolute value of the complex number. So that's going to be the absolute value of z, but that's going to be r, okay? So you could replace z, the absolute value of z, with r, okay? All right. Now we want to go to that form that we had. We said, I better switch to a different color. We said z is equal to, so our complex number is equal to x plus y I, right? So that came from like a previous video when we said that's the form for our complex numbers. Well, we can replace x then with what x equals, r cosine theta. And we can replace y with what it equals, r sine theta. Now, how do I want to write this? I'm going to write r sine theta for the y, and then I'll just put the I right there for now. Okay. Now, they usually change this to write it as r cosine theta. I'm going to do it in 2 steps. We have to have some place for that imaginary number. Then they factor out the r, and it looks like this. This then would be the polar form for a complex number. I'll just put for z. Z represents a complex number. There's an abbreviation for this, and it goes r cis theta. So it's cosine I sine. That's where the cis comes from. Depending on the context, you're going to see that or you're not going to see that. For a lot of these problems that we're going to work on in this section, it doesn't really help to use that abbreviation, but if you use it, that's fine. The theta is the same here as it is here, okay? But for some of the work we have to do, we wind up multiplying things out, and so the abbreviation doesn't always help that much, but it's there. Okay, now, I scrolled up. What is the argument? The argument is theta, okay? So when they talk about the argument for that, they're talking about theta. Okay, so that's where the polar coordinates come from for a complex number. we're going to probably be using it in this form for the most part.